As our next topic, I would like to talk about inverses of inverses. Inverses undo each other, so to speak. Okay, when you think about algebra, you think about f of x equaling x squared, and f inverse equaling the square root of x as inverse functions. If you were to take the square root of x squared, you get just x. If you were to square the square root, you would get just x. And so inverses and their original functions undo each other, so to speak. The one thing that I'll warn you about here is to be careful if you have an answer that's an angle. That angle must fit into the proper restricted area for the inverse that you're looking at. Let's look at an example below. Think about find cosine inverse of cosine of 2 pi over 3. The first thing we need to think about is thinking about what the outside function is asking for. The outside function is the inverse cosine, and so when we finish this particular problem, the answer is an angle. On the inside, you see the original function cosine. This is what I mean by inverses undo each other. Because we have cosine inverse on the outside and the original cosine on the inside, you can think about these two operations as, quote, canceling out. That's not quite perfect notation, but you can think of it that way, and it will get you the correct answer. That being the case, you see that when they cancel out, the only thing that's left is 2 pi over 3. Now 2 pi over 3 may unfortunately not be the correct answer. And so what I need to do is I need to think back and consider the restriction for cosine inverse. Okay, think about for cosine inverse, we restricted our theta values between 0 and pi. Okay, and the question I need to ask myself is 2 pi over 3 in that interval. The little sideways e means is it an element of that particular interval? And yes, we know it is. If we draw that, we have here 0, here is pi, 2 pi over 3 is off over here somewhere. And so it is located in the correct interval. And so the answer to this question is 2 pi over 3, an angle measure. Consider another example. Let's think about tangent inverse of tangent of 7 pi over 4. Once again, pay attention to where your inverse function shows up. The inverse function is on the outside of this set of parentheses. That means that when we get our answer, the answer is going to be an angle. We see the inverse function and the original function side by side, so we can say that those, quote, cancel out, and we have left over 7 pi over 4. But what we've said is we've said that 7 pi over 4 may not be the appropriate answer. We're computing an inverse, and so that angle needs to lie in the proper location. Remember that for tan inverse, the angles had to be located in between negative pi over 2 to pi over 2. Okay, so what we're going to do is we're going to plot 7 pi over 4 and see where that's located. Okay, 7 pi over 4 is a 45-degree reference angle. You can think about for a minute 2 pi as being 8 pi over 4. So 7 pi over 4 is the angle from here around. It's just short. So here's 7 pi over 4. Okay, now for tangent, the actual angle that we end up getting has got to be restricted between pi over 2 and negative pi over 2. So it can't include anything in quadrants 2, or 3. It also can't contain 7 pi over 4 because that's something bigger than pi over 2. What is something equivalent to 7 pi over 4 but has a different amount of rotation? Okay, that is negative pi over 4. So in other words, we see that 7 pi over 4, that angle is coterminal to the angle negative pi over 4, and so negative pi over 4 would be the correct answer to this problem because it falls in the proper restricted area. Okay, looking at another example, okay, on this particular one, I'm going to make a change. Let's say we do sine of sine inverse of 0.35. Now this is different. The difference is the outside function is the original sine function. Okay, that means that when we get done, we're going to be finding a value, not an angle, a value. We see the sine function sitting next to sine inverse, so we say that those, quote, cancel out. And what we're left with is we're left with 0.35. That's not an angle, so we don't have to worry about restrictions as far as the angles are concerned, but we do have to make sure that that's a good value for sine. Remember from other topics that sine lies in between 1 and negative 1. 0.35 is definitely in between 1 and negative 1. And so this is a fine value for sine. Okay, let's conclude by looking at one other example of when you have an inverse on the outside. Let's think about here for a minute. Cosine inverse, cosine of 5 pi over 4. This is sort of an interesting example. So we notice that our inverse is on the outside, which means we're actually looking for an angle measure. We say that here are the two inverses that would cancel out, and so that would leave us with 5 pi over 4. Okay, on this particular one, we run into a problem when we think about the restrictions. For cosine inverse, we think about the restriction on theta as being anything between anything in between 0 and pi. Okay, and if we draw 5 pi over 4, that's a 45-degree reference angle. And let's find out here where it's located. Okay, 4 pi over 4 would be right here. 5 pi over 4 then would be in the third quadrant. Because the restriction on cosine is in between 0 and pi, that means I can't consider anything in the third or fourth quadrants. Well, 5 pi over 4 falls in the third quadrant, and any angle that I have that's coterminal will fall in the third quadrant. So the trouble I have is considering, well, maybe I don't have an answer, or if I do have an answer, how do I figure that out? Okay, here's the answer to that question. This is a 45-degree reference angle. That means that my values of x are -1, y is -1, and r is the square root of 2. So if I were to determine what the value of cosine was at that particular measure of theta, then the actual value of cosine would end up being -1 over the square root of 2, which I realize reduces. In which other quadrant, either quadrants 1 or 2, is the value of cosine also equal to -1 over the square root of 2? The answer to that is quadrant 2. So you see in quadrant 2, your x value is -1, your y value is +1, and your r value is square root of 2. So this angle that's right in there, let's call that theta sub 2, that angle would give you the same value for cosine as the original angle that we were looking at that went from there around. That being the case, then you want to go and you want to convert this to theta 2. Theta 2, okay, that would be a 45-degree reference angle in quadrant 2. That particular angle measure would end up being 3 pi over 4. Okay, so there's the value of that particular inverse. This concludes my lesson on evaluating inverses of inverses.